This is Chapter 4, Homework 3, Rational Expressions, Least Common Denominator and Complex Fractions. Okay, a rational expression just looks like a fraction that's got our variables in it now. Okay, so we are first going to learn how to find the least common denominator. Now, I'm going to teach this even for these the same way I will for these because it can be done. I already know that I could use 18x squared. That's going to be my answer here, but that's because the least common denominator or least common multiple of 6 and 9 is 18 that they'll both go into, and then x squared will go into x squared and x will go into x squared. So I know my answer is going to be that, but how did I find that other than the way I just explained it? All right, so what you're going to do is you're going to factor your denominators. So let me rewrite that down here. When I do the factor tree for 6, it's going to be 2 times 3. Then x squared is x times x. That is a prime factorization, or that's this factored. Now, 9, I can say 3 times 3. I want to do that factor tree. And if I were to do the factor tree, it would end up to be 3 times 3. Okay, that's the first way. Now, so that's the first part of this. So our LCD, there's two ways you can do this for these type, but not down here. Okay, so the same way I'm going to do it down here is going to be the first way here. What I'm going to do is I'm going to write down the very first one. 2 times 3 times x times x. Okay. Then I'm going to go to the next one and ask myself, does this one already have a 3 in it? And yes, it does, so I don't need another one. Does it have a second 3? No. So I need to append that, which means add that to the list. And then do we already have an x in common? Yes, we don't need another one. So our LCD, 2 times 3 is 6, times 3 is 18. I have 2 x's, so it's x squared. And that's the way I'm going to teach it. The other way, which is this one, okay, I'm trying to think, list all of them. Yeah, what the other way, I don't know which way is because I'm not paying attention to that, is, and again, I'm going to teach it this way, but the second way is circle what they have in common. They both have a 3 in common, so if you write one down, they both have an x in common. You write that one down, and then you write what's left over, which would be 2 times x times 3, because we had that one left over. 2 times 3 is 6, times 3 is 18, and we have 2 x's, so it's 18x squared. But I'm going to teach it the way I did up here because of these problems here and after that. Okay, so let me erase that. I am going to write down our two denominators, 12x to the third and 18x squared. So what I'm going to do is I'm going to use the prime factorization for it. I'm going to use the factor tree. I'm just not showing the factor tree. 2 times 2 times 3. And then I have 3 x's. This one here is going to be 2 times 3 times 3. And I have 2 x's. Okay, so what I'm going to do is I'm going to write down my first denominator. And it could have been either of them. It really didn't matter. I just took the first one. So when I do my LCD, I'm going to do it right here because it's going to be a little bit longer and I don't think I have enough room here. I'm going to write down the first one. 2 times 2 times 3 times x times x times x. Okay, so now I wrote down this first one. I'm going to go to the second one and say, do I have a 2 already written down here? I do, so I don't need another one. Do I already have a 3? Yes. Do I have a second 3? No. I need to add that one in there or list that one as well. Okay, so This one here, does it already have an x? Yes. Oops, I don't know why I'm marking that one out. And does it have another x? Yes. So it already had two x's. So I'm going to get 2 times 2 is 4, times 2 is 12, times 3 is 36. So my LCD equals 36, and then I have 1, 2, 3 x squared, or x cubed, sorry. Now, is that the way I do it? No. I look at 12 and 18 and go, what's the smallest number that both of them will divide into? It's 36, and then between the x cubed and the x squared, it's always going to be our higher one. Same thing right here. Okay, 6 and 9 will both go into 18, and then it's going to be our higher variable, the one with the higher degree, so it's x squared. But that's not going to be true down here. It's going to be different, so that's why I'm teaching it the same way through. Okay, so this one was here. What we did was we factored both of them. We listed the factors of the first one and then added any or listed any extra ones. Okay, so here we have 3x plus 1. That's in factored form. Okay, so that's already factored. And then we have 6x. That is going to factor as 2 times 3 times x. So to find our least common denominator, I really don't have room up there. I'm going to try though. Or LCD or LCM, whichever one you want to use, it doesn't really matter. Okay, you're going to list the first one, 3 times x plus 1. Then you go to your next one. We do not have a 2, so I need to list that one. We have a 3, so I don't need that one, and we need this x. So now, a couple ways you can write this. I say 2 times 3 is 6, times x is 6x times x plus 1. That is perfectly fine to leave your answer that way, or, because that's how I'm going to leave mine. Because if I was adding or subtracting this, I might be able to reduce it. So that's how I would write it. But if you wanted to write it as 6x squared plus 6x, it would be perfectly fine. That's not wrong. I just wouldn't, because later on we're going to add and subtract these things, and that way it would be in factored form, and we could reduce it if it will reduce. This one right here is even easier than any of the rest. You write down the first denominator, which is x plus 1. Then, do we have an x minus 1 over here? No. So you're going to list that one as well, and you just found your LCD. Before you can list your LCDs, you've got to factor them. I'm just going to factor them up here. This is going to factor as x plus 4, x minus 4, because it's a difference of two squares. This one here is going to factor as x plus 4, x plus 4. Okay, so to find our least common denominator, you're going to list the first denominator, x plus 4 times x minus 4. Then you go to your next one. Does it already have an x plus 4? Yes. We don't need another one, but we need a second one. Do not multiply this out. Notice I am leaving all of my answers in factored form, because you'll learn why later. All right, right here, we're going to factor. We have 5x. I can factor out of 5x, and I'm left with x plus 3. This is going to factor as x plus 3 and x plus 3. I probably should have done that in red. Oh well. Now, let's do our LCD. You're going to list your first one, which is 5x, x plus 3. Then you go to your second one, and see how they have this in common? All right, so we don't need that first one, because we've already listed it. But we do need a second one. And that's it. Okay, the reason we had to learn that first is so that we can add and subtract, and when we get to solving. Okay, you're really going to want to learn it when it's solving, because it makes our problems so much easier, because we don't have to work with fractions, we can work with whole numbers. Okay, right here, when you add fractions, remember, adding and subtracting fractions, you have to have the same denominator. Once you have the same denominator, all you have to do is work with the numerators. In this case, it was an addition problem, so you were going to say 2 plus 1 and get 3/5. Right here, you can't add the denominators and then add the numerators. It doesn't work that way. You have to get them so that they have the same bottom number. This one does. It's 3. So really what you're doing is you're saying 2x minus 1 plus x plus 4. That's what you're doing. Now you just simplify that. 2x and x gives us 3x. Minus 1 plus 4 gives us 3 all over 3. You always need to simplify this. We learned this in the last section. I'm going to factor a 3 out of the top, and I get x plus 1 all over 3. And now these 3's cancel. 3 divided by 3 gives us 1. So they cancel to give us 1s. So our answer right here is just x plus 1. That's why you do not want to go ahead and multiply these things out, because sooner or later we're going to find that they're just like right here. Now we're going to find it. Okay, so we first have to find our least common denominator. Just like we did up top here, you're going to list your first one and then list the second one, because you don't have anything in common. Now, I'm going to tell you, you need to be real careful because it's subtraction. Always be careful with subtraction. So what I'm going to do is I'm going to take this and I'm going to bring it down here, but I'm going to leave some space. I'm going to take that 7 over x plus 5, and I'm going to leave some space, minus 4 over x minus 5. Okay. And I'm doing that because this is my denominator, but I need my denominator to be this. So I'm multiplying this x plus 5. Let's put parentheses around it because you can't split those up yet. I need it to be this, so it's going to be x minus 5. Whatever I do the bottom, I have to do the top, because this is a form of 1. I'm not changing the problem, I'm just changing the look. Well, over here, I have an x minus 5, but I need it to look like this, so I still need an x plus 5. So I'm going to multiply by x plus 5 over x plus 5. Whatever I do the bottom, I have to do the top. Okay. Now, we now have the same denominator. You have to be real careful because of that minus sign. Okay? Right here, when you distribute, you get 7x minus 35. Now, I look at this and say this is a negative 4. If I did that, I'd say negative 4 times x is negative 4x, and negative 4 times 5 gives me negative 20. Well, some of you don't, which is perfectly fine. But if you distributed that 4, you'd get 4x plus 20. But you got to remember, you're subtracting that whole thing. So now I would distribute that negative. Negative times a positive is a negative. Negative times a positive is a negative. So it didn't matter which way I looked at it. I still got the same thing. And this is all over x plus 5, x minus 5. Now I need to combine my like terms. 7x and negative 4x gives me 3x. Negative 35 and negative 20 gives us negative 55. All over x plus 5, x minus 5. And I can't factor out 3 will not go into 55. So that's my answer. Okay, now these are known as complex rational expressions, and they look really like complex, obviously. Okay, but here's what you're going to do. You're still going to look at everything and find our LCD. Like right here, this has a denominator of 1. This has an x. So on the top, my denominator is x. So then I go to the bottom and I see if I need to add or tack on anything or list anything else. Well, the bottom, all I have is an x in the denominator. Okay, so that's what my LCD for both the top and the bottom. Now watch what happens. I am going to multiply both the top and the bottom by x over x. Okay, I'm just multiplying by a form of 1, and that is perfectly fine. So, but what I'm going to do is I'm going to distribute this x on the top. I'm going to distribute the x on the bottom. So when I do this, when I say 1 times x or x times 1, I'm going to get x. So I'm going to write that down. Now when I say 1 over x times x, if I did that over here, this is what I'd get. I'd get x over x, which is the same thing as 1. Or you can cancel these to get 1s. And so I still have a 1. So what happened was when I multiply this times that, I get 1. So it's plus 1 on the top. Now I have my bottom one. X times 1 gives me x. But now I have a minus sign, and I'm still saying 1 over x times x. It's the same thing as over here, but instead of a plus 1, I'll get a minus 1. I cannot split these x's and the 1's up, so that is my answer. So something that looked really complex doesn't look as bad right now. Okay, so over here, now this one, yeah, a little bit harder, because I've got 3 things. 3 different, actually just 2. The reason is here's the top. So if I'm going to do my LCD or LCM, either way, least common denominator, I'm going to list my first fraction of x, or denominator, I'm sorry, x plus h. Then I go to my next one and I have an x. And I don't like that x on the end, but that's perfectly fine. Now, when I go to the denominator, that's a whole number. That would be h over 1. So I don't really need a 1 over here. It's not going to do anything. So now what I'm going to do is I'm going to list. Now, I am going to multiply the top and the bottom, and I'm going to rearrange this to look like this. X times x plus h. Okay? Over x times x plus h, because I'm just multiplying by 1. Okay. Now, this is where it gets a little bit more difficult for some of you. So what I'm going to do is I'm going to distribute here. Now, I don't have to do it like this because I use canceling a lot, but for you guys, it might be easier to do this over here to the side. 1 over x plus h times x plus h over 1. Then you're going to take the minus 1 over x, or you can just do, let's forget about the minus 1 for now, even though I would do it that way. Yeah, let's go ahead. Let's make that a negative. Times our denominator, our LCD of x times x plus h over 1. Okay, so all I'm doing is I'm distributing this, but I'm doing my work over here. The reason is, watch what happens. This is together, remember. So now these x plus h's cancel, So I have 1 times, and they give us 1. So I just have x. So when I distribute this to here, I'm going to end up with x. Now, this one right here, when I'm distributing this times the -1 over x, again, I'm going to count this as a -1. My x's cancel. I get -1 times x is -x, and -1 times h gives me -h. Oops, and I'm running off the paper. Over 1. Do I need the 1? No. So it's just -h x minus h. That's hard for me to say. So I have -x minus h on the top. Because all I did, this work here, is just distributing here. Now on the bottom, okay, I'm really just saying h. I don't even know why. I was just multiplying that. I don't even know why this is in parentheses. I don't really need it because I'm not distributing. Now on the top, well, let's go ahead. I'm just going to write this as h times x plus h. I mean, the rest I can do is say xhx or xh. Now let's simplify. My x minus x cancels, and I'm left with -h over h times x plus h. This right here cancels to give us -1. H over h is 1. So on the top, I have -1 because I have to have the ones on the top. And on the bottom, I have x times x plus h. If you want to, you can put x squared plus xh, but I don't. Now, it doesn't matter where that negative goes. It can go on the top. It can go here in the middle. It probably should go here in the middle. It can go on the bottom. It doesn't matter. Okay, this one right here. First thing I'm going to do is factor this here. And I'm just going to do that over here. That x squared plus 2x minus 15, that factors as x plus 5, x minus 3. Okay? Now, to find our LCD, I need to do this in red. I don't know why I didn't. I'm changing pens at the wrong time. Okay, so what I'm going to do, that's my first denominator right here. I'm going to write it down. X plus 5 times x minus 3. So if I'm just looking at these two right here, okay, that one there factors like this. So I'm going to list my first one. I go to my second one. Does it look the same? Or do we already have an x minus 3? Yes, we do. So we don't need another one. We've already listed it. So now let's go to the bottom. The bottom, this has x plus 5. Do we already have it listed? Yes. This has a denominator of 1, so we don't have to worry about it. Okay, so what you're going to do is you're going to take the top and multiply it by that, and you're going to take the bottom and multiply it by that. So I really needed to move that over. So what I'm going to do, and that means the whole top. You'll see me in the next video or in class. I won't really do it like distributing. I'll multiply it here and I'll do it here. But okay, so I'm going to move this over. What I'm going to do is, I might as well just do it now. I'm going to multiply this whole thing by x plus 5 and x minus 3. I'm going to put brackets around it because of those. Over x plus 5 times x minus 3. You don't have to have those brackets. It's just keeping them together. So really what I'm doing is multiplying the top and the bottom by a form of 1. Now, you might need to go over here and do your work over here, because what I find is a lot of people need to do it over here because of the way they learned fractions. So you're going to list everything you see. You're going to put 6 over, I'm going to put this in factored form of x plus 5, x minus 3. I'm going to list this, -1 over x minus 3. I'm going to list my 1 over x plus 5, and I'm going to list my 1. Okay, so what am I going to do with my LCD? Remember, I'm going to multiply each of these, but I'm going to do my multiplication over here. I'm multiplying this by x plus 5, x minus 3, over 1. I'm going to multiply this, x plus 5 times x minus 3 over 1. Multiply this, same thing. You're going to multiply everything you see by our least common denominator. Because what's going to happen is you're not going to have fractions within fractions. That is what a complex fraction is. And it's a bad way of having your answers. Okay. So now I'm going to do, so this is just showing my work over here. So what I did was then I distributed this on the bottom, and that's where I got these two. Okay, so let's get our answers now. This is what we learned the other day, multiplying rational expressions. Okay, so our x plus 5's cancel to give us 1. X minus 3's cancel to give us 1. And now we have just 6, which is nice. So we just have 6. Right here, x minus 3 cancels, and I have negative 1 times x plus 5, which gives me negative 1 times x is negative x. Negative 1 times 5 is negative 5. So on the top, I now have minus x minus 5. Now, if you only brought a 1 over here, if you only brought a 1, you'd have minus x plus 5. Well, because of that subtraction there. When you subtract that, it changes everything behind it. You distribute the negative, and you get negative x minus 5. And that's how we got that on the top. Now we got to get our bottom answer. Right here, our x plus 5's cancel. Remember, that goes together. And then 1 times x minus 3 gives us x minus 3. So we have x minus 3. Then we have a plus sign. And when we do this, we have to go ahead and multiply that out here because we've got to combine it with this. Otherwise, I'd have said leave it. But we would really have plus this times this, and we've got to simplify it. Using FOIL, this is going to give us x squared. Negative 3x, positive 5x gives us positive 2x. And 5 times negative 3 is a negative 15. Now again, the reason we are doing that is because we've got to combine it with this. Otherwise, I'd say leave it. So on the top, we have 6 minus 5. I'm going to put my negative x first, even though that bugs me that it's negative, but we'll deal with that in a minute if I have to. Plus 1, because 6 minus 5 is 1. On the bottom, I've got x squared. I really don't need these parentheses, so we don't really have to have them because of a plus sign. X times 2x is 3x. And negative 3 minus 15 gives us negative 18. Okay, so now what we need to do is factor that bottom. This is going to factor as x plus 6, x minus 3. So the reason I factored it, I'm going to leave it in factored form because I factored it. I needed to factor to see if I could have reduced my fraction, if I could have gotten rid of anything like cancel these out. But I can't because this goes together. The best I could do is factor out a negative 1 and been left with x minus 1 on top with a negative out there. But it still is not going to cancel, so this is my answer. Okay. The next section is we are going to be solving rational equations. Okay, this is a real important section. We will use this a lot to get rid of because we don't like to use we don't like to solve equations using denominators or fractions. We want to get rid of them. All right, so what we do, I'm going to go ahead and start this one. I'll do both of these and then I'll quit. Okay, to find our LCD, you go just like we did before. Okay. And again, I'm really bad for on this doing least common multiple. Just know that it's the same thing. Okay. All right, so you list your first one, which is x. We don't have anything else. List your 5, because we don't already have one. Because you always list your first one, then go to your next one. Then go, do we have a 2 over here? No. Do we already have an x? Yes. So our LCD is 10x. So what you're going to do is you're going to take each of these, you're going to take your 1 over x, you're going to take your 1 over 5, and you're going to take your 3 over 2x. And you are going to multiply by your LCD. You're going to multiply 10x over 1, multiply this by 10x over 1. Let's try and write that correctly. And multiply this one by 10x over 1. Okay? And when you do that, you are going to find that you get, now again, I multiply fractions different than some of you all. Most of you are going to say 1 times 10x is 10x over x times 1 is x, and then that reduces to just 10. Okay? I should have moved this over because I'm going into this problem right here. So hopefully I can get this done. Right here, 1 times 10x is 10x. 5 times 1 is 5, and then reduce that to 2x. See, I don't do it like that. I go, x's cancel, 1 times 10 is 10. 5 goes into 10 2 times, 1 times 2x is 2x. I personally would go 2x goes into 10x 5 times, so 3 times 5 is 15. But you all were taught 3 times 10x gives you 30x, and 2x times 1 is 2x, and then these cancel. 30 divided by 2 is 15. That's why when you see my work on a review, you will not see this. You will see me go multiply this times 10x, this one times 10x, and this times 10x. And then what you will see on my review. Now I'm just doing the same thing as I did over here, but you'll see this. The x's cancel to give us 10. That's what we got right there. Bring down your equal sign. 5 goes into 10 2 times, so 1 times 2x is 2x. That's exactly what we did right here. And right here, I'll get 15. So it's a plus sign, and I will get 15. And this is all here. 10 equals 2x plus 15. But when I do this on your, like on my review work, I'll go 2x goes into 10x 5 times, so 3 times 5 is 15. Now this looks like a normal problem, okay? Regular solving equations. Now, I usually will take my 2x to the other side and then take my 10 over here. But seeing my variables are already on my left, on my right, I'm going to take my 15 over here. There's no rule. You can do the other way if you want. It's fine. But this here is going to give me negative 5x equals 2x divided by 2. And x is equal to negative 5 halves, or negative 2.5. If you took this answer, oh, there's something I forgot to do, okay? But if you took this answer and plugged it in here, this left side would equal the right side. Now, because we're solving, we have to worry about our denominator being 0. Okay, so back to the beginning, I forgot to do our restrictions. That's really important to do, and I forget because I always check at the end. It doesn't matter if it's at the end or if it's at the beginning. But our restrictions, meaning what's going to make our denominator undefined. Right here, x is not allowed to be 0. It can be anything here. Here it can't be 0 because 2 times 0 is 0. That would make the problem undefined. Same thing here. Our restriction here would be x cannot equal 0. It can be everything else. This has a denominator of 1, so it's fine. So if we're going to do this problem right here, to find your least common denominator, that has a denominator of 1. We don't have to worry about it. Write down your first denominator of x. Go to your next one. We already have one. We just found our LCD. All we're going to do is multiply this times x, and this times x. Now, that's how I do it. And I just say x times x is x squared. Minus, right here, my x's cancel, so I'm left with 17. Equals, right here, my x's cancel, and I'm left with 8. But if you can't do that, here's what you're going to do. You're going to come over here and you're going to list everything. You're going to list your fractions, just like this. And you're going to do this multiplication that I did here over here. X over 1, x over 1. And you're going to get your answer. This gives us x squared. This here, our x's cancel. Oh, see, I'm so used to doing that and getting negative 17. You probably are going to do negative 17 times x is negative 17x over x, and then you get negative 17. Same thing. You just multiply, then reduce. I reduce, then multiply. It's fine. And right here, you're probably going to do 8x over x, which reduces to 8. That's x squared minus 17 equals 8. And again, I would do it like this, just like I did it here. Okay, now, let's see. Because we have an x squared, you can factor, you can use square root property, you can use completing the square or quadratic formula. I'm used to factoring, so I'm going to take that 8 over to the other side, even though on this one you could use square root property. We're going to subtract 8. And you are going to get, oops, this cancels, this does not. Okay. X squared minus 25. Well, this factors is x plus 5, x minus 5 equals 0. Here, x plus 5 equals 0, just like we learned in the last chapter. X minus 5 equals 0. So here you're going to subtract 5. Here you're going to add 5. And your answer is going to be x equals negative 5 and x equals 5. Now, square root property probably would have been faster, but when you had x squared minus 17 equals 8, I would have done the square root property. I'm just used to factoring. But I knew what it was going to be, so I probably would have switched. I'm going to add 17 to both sides, but here's what I have a problem with. Is you'll get x squared equals 25. And then some of you will take the square root property, or most of you will. But the problem is you'll give me the answer of x equals 5. And that's not all the way right. It's only half right. Remember, when we put that square root symbol in there, it's a positive and a negative 5. So x equals negative and positive 5, or positive and negative 5. I don't care how you write your answer. You can even write it like this for me. I don't care. Okay? All right. I'm going to pick up with this in class.